Welcome to today's seminar. My name is Beth Mashesky, and I'm a research specialist here at the Illinois Sustainable Technology Center and co-organizer for the seminars. Our next seminar will be on November 2nd, discussing the use of gas technologies for water and wastewater treatment and aquaculture. Presented by Sudhir Brahmavat, President of Technology Services. I would like to ask everyone here in our audience to please silence or turn off electronic devices as we are recording this seminar. Also, we'll hold all questions until the end of the presentation, at which time we will come around with the microphone so that our online audience can hear your questions. For those viewing online, you can type in your questions anytime, and then we'll address those at the end as well. And with that, I am very pleased to welcome today's speaker, Stewart Harris. Stewart is the Director of Marine and Environmental Stewardship at the American Chemistry Council's Plastics Division, where he manages the Marine Debris Program. He is also Chair of the Advocacy Committee for the Plastic Industry's Global Action Team, which implements the Declaration of the Global Plastics Association for Solutions for Marine Litter. A part of that global declaration, 69 signatories and 35 countries have implemented over 260 projects addressing marine litter since 2011. Stewart has a Master's of Science in Marine and Estuarine Environmental Science from the University of Maryland and a Bachelor's of Science in Biology from Bucknell University. Please join me in welcoming Stewart.
Thank you very much. I appreciate that. I'm sorry that I couldn't be there in person today, but do appreciate the opportunity to give a webinar. I will try to keep it brief so that we have plenty of time for questions or comments at the end. But I thought it would be helpful to run through just a few key points before we get there. So. There we go. So just to give you a basis, Beth mentioned I work for the American Chemistry Council's Plastics Division, which is a group within the American Chemistry Council. We have a number of member companies that are members of the Plastics Division and support what we do. It's interesting to note that our members produce plastic resin pellets or flakes, but plastic resin. They don't produce actual products, so they sell the plastic resin to another company, a converter, and then that converter turns the resin into a product like a bottle or a tray or what have you, and then that gets sold to a brand owner company, which then fills it and brands it, and that's how you get your plastic packaging. Quickly to give an overview of a few points we want to cover today, I thought I'd start off with giving our view on marine debris, and then a slide about why we use plastics, some information on the latest science and the global declaration that Beth referenced, and then also partnerships that we are a part of, which help us to accomplish some of those 260 projects that were mentioned. So our view as the plastics industry is that plastic and other litter in the environment is unacceptable. Plastics deliver significant benefits to society, whether we're talking about energy, greenhouse gas, and other resource savings, or innovations for healthcare, reducing food waste, improving the quality of life. But these benefits are lost if litter harms our natural environment and if plastic gets into the ocean. Something that some of you all may be familiar with is life cycle assessment. This is from Franklin and Associates, actually back in 2008, did a life cycle assessment, and they looked at different kinds of packaging. They looked at coffee, which is this example. They also looked, I think, at milk and tuna were the other two. But the coffee example shows a good picture about why we use plastics to start with. You take a steel can, which coffee used to be packaged in, had about an 80% recycling rate at the time of the study. You compare that to a plastic canister, which back in 2008 we didn't have very high recycling rates for what we refer to as tubs and lids, so those plastic containers. And then you take the plastic brick pack, so it's a multi-layer package, kind of that vacuum sealed brick of coffee. And looking at the greenhouse gas emissions from those three, the steel can, even though it has an 80% recycling rate, has a much higher greenhouse gas emission because of the energy it takes to produce the can and the amount of material that's used to package that when you compare it to the plastic canister or the plastic brick. That multi-layer brick pack uses a very small amount of plastic to provide the same benefit as the steel can from a packaging standpoint. A more recent study, which was done by TrueCost in July of last year, used what's referred to as natural capital accounting, which is kind of within the broader life cycle community. Natural capital accounting is kind of a subset of that, if you will, and looked at the environmental cost of plastic. Back in 2014, TrueCost did a study for the United Nations Environment Program on the cost of plastic, came up with a number of $79 billion. But they didn't look at the cost of alternatives to plastic or how to reduce the cost of plastic. This study updated that 2014 report, and unfortunately the cost of plastic has gone up from a natural capital accounting standpoint to $139 billion. But when compared to alternatives, it was almost 4 times. Alternatives were almost 4 times higher in terms of the natural capital cost of those, and that really has to do with the benefits of plastic and why we use it in the first place, in terms of not very much material is needed. It has a lot of durability benefits that alternatives, glass, metal, paper, things like that don't have. So this again was a look at why we use plastic versus alternatives. Another reason that I mentioned earlier was reducing food waste. I remember a few years ago I was in the grocery store and I saw cucumbers wrapped in plastic, and I didn't know why they did that. What's interesting is a cucumber is 96% water, and when you pick it, it starts to lose that water, and after about 3 or 4 days, you can't sell it anymore because it's gotten so shriveled and from losing all the water. If you use just a very thin 10 mil layer of polyethylene film over that cucumber, you can keep it fresh for 14 days and improve the chance that product will be sold and make it to its final destination. The same is true for other products as well. Salads, the bagged salads aren't just a convenience, but you actually use less salad to produce what's in that bag than if you were to try to do it on your own. You'd have a fair amount of waste. So it just gets at how we can reduce food waste. It's also important to keep in mind that packaging represents about 10% of the environmental impact of a product when you're talking about food. Sometimes more, sometimes less, but it's right around 10%. And if food is wasted, there was an FAO report I saw the other day, and I can't remember the exact quote, but the amount of greenhouse gas emissions, water, energy, what have you, that go into producing that food, if it's wasted, then we lose all of those impacts, not just the impact of the packaging itself. So a little bit on the latest science and the global declaration. According to NOAA, the official definition of marine debris is any persistent solid material, manufactured or processed, directly or indirectly, intentionally or unintentionally disposed of, or abandoned in the marine environment or the Great Lakes. So just to get us all on the same page, typically when we talk about marine debris, we're usually talking about packaging, but it does also include derelict vessels, derelict fishing gear, other types of storm debris from the hurricanes we've recently had. Microplastics, NOAA has kind of, well, the scientific community has narrowed in on pieces that are less than 5 millimeters, can come from a variety of sources. If you look in the bottom right picture of the finger, those are microbeads, which are a subset of microplastics that used to be found in rinse-off cosmetic products. but with the microbreed ban that went into effect this year, those are no longer included in many rinse-off products. This is a study that Jenna Jambeck and colleagues did back in, it was published in 2015 in Science Magazine, that looked at where is all the marine debris coming from. Where's the plastic in the ocean coming from? They estimated, doing some modeling, that 8 million metric tons per year of plastic is dumped into the ocean. You may have heard that referred to as one New York City dump truck of plastic dumped into the ocean every minute. So it is a significant amount of plastic and a significant problem that we're trying to be part of the solution for. When you look at where it's coming from, it was interesting that 5 rapidly developing economies in Southeast Asia, where the economy has developed, the people have more money, they're buying more consumable goods as they're moving out of poverty. However, the waste management infrastructure hasn't kept pace with that economic development. So not unlike a situation that we may have seen in the U.S. in the in the 60s and 70s, when we didn't quite have the waste management infrastructure that we have today, we're seeing a situation perhaps even worse in Southeast Asia, and the products that are finding their way into the environment are plastics. So in 2011, at the 5th International Marine Debris Conference, a group of trade associations, plastic trade associations, really led by ACC and Plastics Europe, released a global declaration, which we refer to as the Declaration of the Global Plastics Associations for Solutions on Marine Litter. And within that declaration, it included 6 key points that we would address that we would follow in trying to address marine debris. Every 2 years, we do a progress report. The last progress report, we had 260 projects. We're actually in the process of doing our next progress report, which hopefully will be completed in December of this year, but certainly will be out by next year. And we're continuing to expand those projects. We've grown from, I think the next, no, it's not, okay. So we've grown the number of associations and the number of countries to 69 associations. Actually, I think we might have 70 now. We just had a new association sign on recently from 35 countries. Within the declaration, these are the 6 points, really looking at partnerships, supporting research, promoting enforcement of existing laws, spreading knowledge, enhancing recycling and energy recovery opportunities, and stewarding plastic pellets. So plastic pellets are the plastic resin pellets that our members make. Here, this is the graph I was looking for. So we started with 47 associations, and we've grown that to what we have today. Actually, 70 is the number today. And you can see the map of the coverage. So we're continuing to expand. So within our approach to marine debris and within the declaration, we really look to waste management as the key. The Jambeck report showed that the lack of collection, processing, handling infrastructure in developing countries was the primary source of marine debris, with 50% of the plastic inputs in the ocean coming from just 5 countries. But we have similar problems here in the U.S. The picture on the far left is actually taken in Washington, D.C. in the summer, outside of a federal office building. And just where the bricks are, just around the corner from that trash can, is a storm drain. And so you can see the litter that's on the ground very easily can get washed into the storm drain. The picture in the center is a trash can from a public park in Hawaii, where we did a project to actually replace open trash cans like this with lidded cans. And then the picture on the far right is also in Washington, D.C. in the summertime. Incidentally, it's across the street from the picture on the far left. And the 2 bins, the blue and the black bins, where you've got recycling and trash, are outside one of the Smithsonian facilities in D.C. They're privately maintained. They're well maintained, and so they're not contributing to litter. In terms of partnerships, I thought I'd run through a few of the partnerships that we've engaged with to give you a sense of what we've been trying to do to address marine debris. One that we like to focus on is an effort with Keep California Beautiful and state parks and transportation out in California, where we help to put recycling bins on beaches. Interestingly, in California, at a lot of beach access points, they just had trash cans, and many people, being environmentally conscious and also didn't want to put their recyclables in the trash. So they would put them next to the trash, where they would hope that the recyclable would get picked up, or if it was a bottle with a deposit, that someone would get the bottle and be able to return it for a deposit. Ultimately, what would happen, though, is wind or storm or what have you would potentially wash that item into the ocean, contributing to marine debris. So we were able to add a number of bins to beaches, rest stops, and other areas, and divert about 45 tons of plastic and over 100 tons of other recyclables from landfill through this project. We're also able to just provide more capacity to keep items from becoming marine debris. Some additional partnerships that we've worked with up in Rhode Island, a group called Save the Bay, Narragansett Bay, is the lead for the International Coastal Cleanup on Narragansett Bay. And they've noticed over the years that they've been doing it, certain sites are chronically littered. They would clean them up on a weekend. By the middle of the next week, they would be littered again. And so they were looking for an opportunity to do a more in-depth project with the city of Warwick, Rhode Island, to address the underlying cause of that chronic littering at 4 sites. We were able to partner with Save the Bay to provide a little funding to help them do that, and it's a project that's actually ongoing right now. Beachy Clean is a project that NOAA, the National Oceanic and Atmospheric Administration, supported initially down in Virginia Beach, where it was an anti-littering media campaign that they would put signs on buses and other things down at the Virginia Beach resort area to remind people to not litter. We have come in to help support expansion of that project to other areas within Virginia Beach. There are different communities, not unlike you would have up on the Great Lakes, where you have kind of residential, more hotel, and then the commercial areas. So continue to move forward with that program, which has been successful. It's done some videos and other things to reduce littering on beaches. The Hawaii project that I referred to earlier was at Ala Moana Park. We went in and did a litter survey in partnership with the city and county of Honolulu, and found that at the park, the unlidded bins that I showed before were a significant cause of marine debris. They're located right near the water. It's relatively windy, and you also have a higher homeless population in Hawaii that tends to dig through the trash, and so you were getting a lot of litter and a lot of marine debris. We entered into an MOU with the city and the county to install covered lidded trash bins like the green one you see here on the right. And then the city and county agreed to maintain those on a regular basis to make sure they don't overflow. We have a baseline litter survey that was just completed. The bins are being installed hopefully in the next month. And then once they're installed, we'll come back and do a follow-up litter survey to see what the difference was between pre and post installation of those bins. But we're expecting to see a significant reduction in the amount of litter. On the Trinity River, we worked with EPA's Trash-Free Waters program and also the Meadows Center at the University of Texas to develop an Adopt a Spot program. So it was an interesting project where they developed an online mapping tool, and they provided information on the different sections of the river or creeks along the Trinity River where people had adopted sections of it to do litter pickups and what have you. It also includes a feature where people can report illegal dumping, or if a community group wants to go out and do a trash pickup or a stream clean type event, that they can then contact whoever has responsibility for that site to get out there and clean it up. On the policy front, I mentioned the Microbead-Free Water Act, which went into effect this year. ACC was very involved in supporting passage of that. We worked closely with folks on the Hill and some of our colleagues here at other associations in the cosmetics industry to develop that legislation and move it through the process. More recently this year, we've been supporting the Save Our Seas Act, which passed the Senate. Reauthorizes the NOAA Marine Debris Program and also provides some additional authority for the State Department to support international efforts to address marine debris in developing countries. In terms of international partnerships, we've gotten involved with the Zoological Society of London on a program called Networks. It's an interesting project where ZSL works with local communities in the Philippines to recycle either abandoned or discarded nylon fishing nets. A company called Interface then takes those nets that are turned into polyester thread, which are then used to make carpet tiles. So it's a neat way to both get marine debris out of the environment, but also and provide a little bit of additional income for some of these communities and some of the fishermen in the communities, and then also recycle into a product that then can be sold and used, reducing the reliance on virgin feedstock for those carpet tiles. The Trash Free Seas Alliance is another group with which ACC has been very involved. It was pulled together by the Ocean Conservancy, and as you can see, it's a consortium of both private sector, environmental groups, academic groups, and what have you, looking to address marine debris and really focusing on the findings of the Jambeck paper. So as I mentioned, Jen Jambeck's study looked at the sources of marine debris into the ocean. From that study, the Trash Free Seas Alliance supported the development of a report called Stemming the Tide, the McKinsey Center did, that looked at how do we address leakage of plastic into the ocean from these 5 rapidly developing economies in Southeast Asia. Following the Stemming the Tide report in 2016, the Trash Free Seas Alliance released a report called The Next Wave, which effectively was how do we finance investments in waste management infrastructure in Southeast Asia to address the leakage of waste into the ocean. So that's been the general flow of the Trash Free Seas Alliance. Just recently, at the Our Ocean conference, I think it was yesterday. The Our Ocean conference is going on now in Malta, but I believe it was yesterday. The Trash Free Seas Alliance and the Closed Loop Partners announced the development of, I guess it's the release of a new fund called the Closed Loop Partners International Fund, which will support the development of waste management infrastructure, collection, what have you, focused on Southeast Asia. It's a $150 million fund that they're working on raising. ACC and Trash Free Seas Alliance have been very supportive and working with the Closed Loop Partners to develop this model. It's based on the Closed Loop Fund in the United States, some of you all may be familiar with, which I believe was started or initiated by Walmart to help improve recycling infrastructure in the U.S. So it's a similar model that's been used domestically that we're working to apply internationally to address the lack of waste management infrastructure. And just to talk about recycling and recovery, we've been very involved in promoting recycling, working with Keep America Beautiful and the Ad Council on the I Want to Be Recycled campaign. Some of you all hopefully are familiar with, you've seen ads for. We've been very supportive of America Recycles Day, which is coming up next month. We've also worked with the Recycling Partnership. Back in 2015, we really started to see some significant progress. The Recycling Partnership is another group that also provides grants and other support to communities to increase recycling. Replacing some of the small bins with the 55-gallon carts so we can get more recyclables into the system. Non-bottle rigids. When I mentioned the coffee study earlier in that plastic canister back in 2008, was not readily recycled. You can see the increase in polypropylene, which is one of the materials for yogurt cups and butter tubs and things like that. So we're seeing more recycling of non-bottle rigids over time, which is a positive trend in getting more plastic into the recycling stream. One of my favorite programs that we have here at ACC is the WRAP program, which is the bag and film recycling program. So grocery bags are made out of polyethylene film, low density polyethylene film, but dry cleaning bags, bread bags, Ziploc bags, any kind of wrap around cases of water, soda, toilet paper, diapers, what have you. The majority of that film, of that overwrap, is polyethylene, which can be recycled into things like Trex or composite building products, composite lumber, but you can't put it in your curbside recycling because it gets contaminated. It fouls up the equipment at the material recovery facility, and so you need to take it back to your grocery store or the retailer, which not everyone knows about. So the WRAP program helps to promote that and work with communities to promote that infrastructure to ensure that people know that you can take it back to your grocery store, or some other retailers also accept bags and film, and making sure that we get more of that film into the recycling stream. Recently, we've been working with North Carolina on a coastal WRAP program, which again is one of my favorite projects because bags and film also often find their way into marine debris and are a very visible component of marine debris. And we supported some radio advertisements to get the word out about the WRAP program in North Carolina. Looking at the increase, we're seeing more bag and film recycling. We have a goal. I don't have it in here. We have a goal to double the amount of bag and film recycling by 2020 to 2 billion pounds. So it's an ambitious goal, but it's certainly something that we're working toward and we should be able to achieve. Oops. Oh, apologize. So lastly, I do want to talk about plastic pellets, resin pellets, the material that our members make. There is a program called Operation Clean Sweep that celebrated its 25th anniversary just recently. And it's a program designed to capture pellets to make sure that they don't end up in the environment. Back in the 80s, we were seeing a lot of resin pellets in the environment. Operation Clean Sweep came in just as some best management practices to ensure that as pellets are being loaded and unloaded into rail cars and other means that we're making sure that we're not spilling those pellets into the environment. So that's a program that has expanded internationally. It has been very successful at reducing the amount of pellets that are lost in the environment. And with that, I'll thank you and turn it back over to Beth if we want to open up the lines for questions.
Okay, thank you for a great seminar. We'll start with some questions in our audience here, if there are any.
Has anyone taken an obsolete oil tanker or container ship and outfitted it to go to some of the places in the ocean where the plastics are highly concentrated, collect them, and figure out how to dispose of them?
That's a great question. And hang on, I'm just writing myself a note. When we're referring to the areas in the ocean where plastics are highly concentrated, typically those are the 5 gyres that are in the ocean. The Pacific garbage patch is something that has been referred to before. We need to keep in mind that while the concentration of plastics in the gyres within the ocean is high, it's still relatively low when you compare it to the amount of plastic that we find on beaches. And so going out, taking a ship out to collect that plastic is an extremely expensive and it's questionable whether or not the bang is worth the buck. That being said, there is a project called the Ocean Cleanup that Boyan Slat has developed over time, and he has developed a series of trash booms, if you will. They're kind of pie-shaped pieces that he's using sea anchors so they wouldn't be fixed to the bottom, but sea anchors which would allow them to float, but float more slowly. And the concept is that these booms of the ocean cleanup would help to aggregate the plastic in higher concentrations, and then a ship would be able to go out and offload the plastic particles, which typically are microplastic size or slightly larger, and then bring that back to shore for either recycling or disposal, depending on what they're able to do. That being said, we as the plastics industry and also the Trash Free Seas Alliance, we've chosen to focus our limited resources on trying to keep plastic out of the ocean in the first place, and look at the leakage points in Southeast Asia, because we think we can make a more significant impact on marine debris. That being said, at some point we are going to have to go out and clean up all the plastic that's in the ocean. So projects like the Ocean Cleanup that Boyan is working on will be important.
Okay, we have another question here.
Yes, I was wondering on the one slide near the end where you showed the plastic film that's being recycled, and you showed some of it is being exported. Right there, I guess it says for use in the U.S. and then for export. What do they use it for again in the U.S.? Can they remake it into other plastic wrap? And then for export, what countries is it exported to, and what do they use it for there? Thank you.
That's a good question. Typically, plastics film in the U.S. is used to make composite building products. So the Trex lumber, and I hate to always use Trex, but it's the one company that I know that uses plastic bags and film to make composite building products. But that's the typical use in the U.S. In terms of export, it's a more general category. A significant amount of it is likely exported to China. China used to be a large purchaser of recycling. Some of you may be familiar with the Green Fence or the National Sword programs in China, where they are reducing the amount of recyclables that they are purchasing from other countries. The U.S., which, not to get into a lengthy discussion, but as a large purchaser of recycled products, that has had an impact, a short-term impact on the recycling markets globally, which will get sorted out over time. But for export, I'm not familiar with all the uses of film. Most of it, as I said, in the U.S. goes into composite building products, but in other countries, in Indonesia, for example, they're exploring using recyclables, which would include film, and mixing them with tar and other components as a composite road building surface. Oftentimes in hot climates, if you mix plastics in with your tar and other aggregate, you get the roads can withstand higher temperatures from heat and things like that. So not a complete answer to your question. I apologize.
Okay, we'll take a question from online now.
This one's from Sherry. Have paper bags been included in any LCAs for coffee packaging options?
That is a good question. I believe the answer is yes, because typically with an LCA, they look at various types of packaging components. I know with the True Cost study, that was a natural capital accounting, so not a full LCA, but a version of an LCA, that they did look at paper bags for packaging of various products. But I guess to finish my answer, I don't have a good analysis of what the side-by-side comparison of paper versus plastic when you're talking about packaging coffee in terms of the greenhouse gas impacts would be.
Okay, do we have another question?
What is the status of expanded polystyrene recycling, and what initiatives do you have at ACC to increase the recycling of EPS?
Well, thank you. I have a colleague here who works more extensively with expanded polystyrene or EPS recycling, but we talk quite often. There are a number of opportunities to recycle expanded polystyrene or foam cups. DART, which is a member of our one of the subgroups we have here on food packaging, has been doing a lot with densifying and turning EPS into things, picture frames, rulers, things like that, that they are able to recycle polystyrene into. But a more recent project with polystyrene has been with a company called Agilix, which is based on the West Coast. And they've used a pyrolysis technique, which effectively you put material into a chamber and you heat it up in the absence of oxygen to turn that material into gases and liquids. And then you separate out those gases and liquids and can use them for various chemical refining processes. With what Agilix has been able to do is take that pyrolysis technology and turn expanded polystyrene materials like foam cups back into styrene oil, which can then be refined to produce styrene and then polystyrene, and then you have a polystyrene resin pellet, which you can then turn back into a foam tray or a foam cup. So Agilix has actually been able to demonstrate a closed loop recycling, if you will, of polystyrene, which is a very exciting development. From a cost perspective, I think the cost is still a little high for the U.S., but it is being looked at in a number of developing countries where it makes a little bit more sense economically, and certainly as the process gets further refined, the economics will improve, and I suspect that we'll see greater recycling of polystyrene, chemical recycling of polystyrene back to the feedstock styrene so that you could produce that foam cup again.
Do we have another question in the room?
Yes, my question is, can you give us a sense of the number of retailers that are participating in the WRAP program? And have you sought partnerships with some of the really big retailers like Walmart and Kroger, for example? And what percentage of those partnerships are retailers are participating? I haven't seen the WRAP program, and I keep an eye out for that, but at my grocery store, there is a repository that says recycle your bags here. Doesn't have the WRAP logo on it, and I've always wondered what they actually do with those. So can you give us a little more information on that, please?
I definitely can. One thing that I would point you to, and I believe the website is filmrecycling.org. Computer's being a little slow. But filmrecycling.org, I think, is the WRAP website, which has a lot more information. I don't know exactly how many retailers we have on board, but it is a significant number of retailers across the country. We have, to my knowledge, we don't have any projects in Illinois right now, but Washington State, Connecticut, North Carolina, Virginia, are some of the states that we have worked with to expand the WRAP program. And we are presently looking at creating a toolkit that communities could download to kind of implement their own WRAP program, if you will. It sounds like you already have the infrastructure in place at a number of your grocery stores. In terms of Walmart and Kroger, I know Kroger has been a member. We've worked with Harris Teeter. I don't know if we've worked with Walmart. We have worked with Target. The approach at this point really has been at the community level, where we would work with the local store or the local branch manager that would have a number of stores under them, as opposed to at the national level. But we have developed partnership with some of the larger retailers, which typically is a requirement for getting a WRAP program rolled out in a community. We need that, the big box store or the large grocer to be an active participant in it, because they typically have a number of facilities. Food Line, for example, has been a partner with us on the North Carolina program to take back bags and film. The percent, I don't have that statistic, but I believe it is on the filmrecycling.org website. And I definitely appreciate the question. In terms of what happens with that film, many of those retailers are required to recycle the film in the back of the store already. So when they get pallets of things delivered, oftentimes it's wrapped in polyethylene film. And so that material has to be recycled. So they'll take the material from the front of the store, if you will, where you're dropping off your bags and film. They'll mix that with the back of the store recycling, and then that gets sent out typically to a company like Trex, which will shred it up and mix it with other materials to make the building products and what have you.
Okay, we'll take a couple of our online questions now.
Question on a chart shown on one of the earlier slides titled Plastics and Sustainability. Wondering how the various ratios were determined and why the blue section for ocean damage is so slim for both plastic and its alternatives. Do you have more information on that study?
Yes. So that slide, and I'm having a little trouble with my computer right now, so I can't go back to it. But that study was from the True Cost report, which is available on actually on ACZ's website. But if you Google True Cost Plastics and Sustainability, you should be able to find the report to get the more detailed information. Interestingly, on the ratios for the ocean piece of it, which were not as large, that had to do with the impacts on the ocean and how they developed the ratios. When you look at the impact of plastics on the ocean versus the impact of alternative materials on the ocean, I believe you ended up with a similar number from the natural capital cost accounting methodology that True Cost used. When you looked at other impacts, greenhouse gas impacts from things like food waste, or when you look at product lightweighting, where you have transportation involved, that's where you saw some of the larger impacts. So I hope that answers your question, and I apologize that I can't get my computer to go back to that slide.
Okay, I've got another one. What are the opportunities and obstacles for biodegradable, compostable plastics?
Okay, hang on real quick. Just I wanted to. Where is True Cost? So this is just for the previous question, that's that graphic, and if the person wants to grab the information from the bottom of the screen, which hopefully you can see, that's the study. So could you repeat the question? I apologize.
What are opportunities and obstacles for biodegradable, compostable plastics?
That's a great question, and I appreciate it. There are many of both. Biodegradable plastics do have some significant opportunities when we're looking at things like marine applications, fishing gear type applications, where there's a high likelihood that whatever that article is could be lost in the ocean. So if you're talking about traps or different kinds of gear, fishing gear, certainly aquaculture related gear, we do have a high chance of loss. Biodegradability does have there are good applications for that. Some of the obstacles to biodegradability are, first of all, the perception. And there have been a number of studies looking at biodegradable plastics and the public perception that those items, the people are more likely to litter an item that they perceive will break down in the environment, as opposed to properly disposing of that item. Biodegradable plastics often are designed to break down in what's known as an industrial composting facility. So high heat, humidity, very controlled environment where they compost other organic materials. They're not designed to break down in the ocean. which is typically a cold and if the object sinks, dark environment. The other challenge with biodegradables is if you are trying to protect a product, a food product or other product from the environment, so from moisture, from bacteria, from other things, it's very difficult to use a product that breaks down with those conditions, sunlight, what have you. It's hard to meet both criteria, especially if you're talking about food packaging. Another obstacle to using biodegradables, getting back to the composting facility, is they can't be mixed with recyclables. And so oftentimes your biodegradable plastics will contaminate your recycling stream if you don't have a separate stream, a separate composting stream for those materials. So if someone is presented with a single stream recycling opportunity or a trash can, they're going to put that biodegradable item into the recycling bin, which is then going to contaminate your recyclables because the machinery can't tell the difference between a PET bottle and a biodegradable bottle, or whatever substance it is. But all that being said, there are opportunities for biodegradables, but it's not a silver bullet to solve the marine debris issue. We really need to focus on, and we have been focusing on keeping stuff out of the ocean to begin with, and making sure that if it's in a developing country, we're working on collection and processing infrastructure. If it's in a developed country like the U.S. and Europe and others, we're really focused on some of the littering and behavior issues that we have in terms of letting things get into the ocean. One more point, just to like to build on the biodegradable question. There's something that's often confused with biodegradability, which is bio-based. And bio-based plastics are not biodegradable plastics. So biodegradable is something that would break down into its component parts, carbon and other pieces that it's made out of, under some specified set of conditions, whether it's industrial composting or natural conditions. Bio-based means that we've derived the plastic from a renewable resource. So for example, one of our companies, Braskem, makes polyethylene out of sugarcane. So you take sugarcane, you refine it to make ethanol, you convert that to ethylene, and then you can convert that to polyethylene, and then you can make your whatever polyethylene products you want, whether it's high density or low density. But that polyethylene product that was made from a bio-based, that's considered a bio-based plastic, has a lower carbon footprint because it was made from sugarcane instead of natural gas, but it's not going to break down. It's not going to break down in a biodegradable kind of way. It can be recycled just like other polyethylene. It just was sourced from a different feedstock.
We have another question here.
Yes, on your slide, what are microplastics? You mentioned briefly plastic microfibers in clothing, but I've got the impression that this is a problem that's much larger than what we've been exposed to in the media. That, for example, American Scientist has a weekly email, and every so often it'll have another recent study that was just published. Someone goes to the Marianas Trench and some of the most remote places in the ocean, samples the marine organisms there, and finds traces of microfibers in the sea life. I guess it's been shown that some of the microfibers in tissues can act as a surface that contaminants will settle on, so that people consuming sea life that has the microfibers in it will get a dose of contaminants more than they would from ordinary seafood. I'm wondering, what can you say about what's being done about that problem?
Well, there's a lot there, and we probably could dedicate an entire webinar to talking about contamination of microfibers and microplastics and seafood. But I just wanted to make a few clarifications. So within the category of microplastics, there are a number of subcategories. One is microbeads, which are the manufactured beads that are added to certain products, previously added to rinse off cosmetic products, some of your face scrubs and what have you, but are also used for things like sandblasting or soda blasting as an alternative to silica. Then you have the plastic resin pellets or flakes, which are what are the virgin plastics that are then used to make other things. Those are typically considered microplastics because they're less than 5 millimeters long. And then you have microfibers, which is something that is a new development in terms of the scientific literature. And that's where you have an article of clothing, of synthetic clothing, like polyester, like a fleece jacket, or some of the synthetic fabrics that, you know, Under Armour and Nike and what have you, that all the kids are wearing these days. Those fabrics, when you wash them, tend to shed, just like normal fabrics made out of cotton tend to shed, and the fibers break off and are referred to as microfibers because they're less than 5 millimeters. The science on microfibers has been developing a lot in the last year and a half. It's a relatively new area of contamination, if you will, where we're finding more and more about microfibers. There really isn't a lot known in the literature. There have been a ton of studies done in terms of shedding. Patagonia supported some work out in California on how much fleece jackets shed. There have been a number of products developed. The Coral Ball was developed by a group up in New England called the Rosalia Project, which is a microfiber catcher you can throw into your washing machine, and it would aggregate a lot of these fibers so that you could then clean and dispose of them like you would lint from a dryer. So microfibers is a developing area in terms of the scientific information that's available. Contamination of microfibers or contamination of microplastics is something that we do know a little bit more about, and there have been a lot of studies done by academics throughout the world, also by the joint group of experts that is within the United Nations Environment Program. It's called the GESAMP group. It's the joint group of experts on, I think, the environmental aspects of marine pollution is, I think, what that acronym stands for. And the science on that is a little bit mixed. For the most part, the studies, and there have been studies by Albert Coleman's on microplastics contamination, where plastic as a petroleum-based product tends to attract a lot of the legacy contaminants that we see in our oceans, and those contaminants will then stick to the plastic. And where the question is, you know, a fish eats that plastic. The question is, does the contaminant stay on the plastic, or does the contaminant go into the tissue of the fish? And that's where there's a little bit of uncertainty. At this point, it does not appear as though the plastic just releases the contaminant. It's more of you have to look at what's the contaminant load in the fish versus the contaminant load in the plastic to figure out where stuff goes. Where your question was getting is this newer area of microfibers and nanofibers, where a microplastic is typically too large to cross a cell membrane, and so it gets into the digestive system of an organism, and we have to figure out whether or not, or a scientist has to figure out whether or not that contaminant migrates from the plastic to the tissue. When you start to deal with microfibers and nanofibers, if that particle is small enough, the particle itself could move with the contaminant into the tissue of the fish or organism. And that's where a lot of research is being done right now to figure out, you know, what are the health impacts of that? What are the implications for population dynamics? Is it going to, you know, affect population in terms of reproduction, in terms of health? And we just don't know. So that's something that is being looked at right now, and I can't say that we know the answer.
We have a few more questions online, Stu, if you're able to stay on for a bit longer.
Yes, I definitely can.
What do you do with the plastic waste collected from the ocean?
Well, that's a great question. There are a number of groups that are looking at opportunities to recycle that plastic or to convert it into to petrochemicals and other chemicals. You may have seen that Adidas has their, I can't remember what they're calling it, but it's basically an ocean plastic shoe where they're collecting plastic off beaches. They're turning that plastic into thread, and then they're making shoes out of it and selling it. Dell and actually I was on a webinar earlier today with a woman from HP who was talking about how they have been collecting plastics, not in the ocean, but they're referring to it as ocean-bound plastic from a project in Haiti, where they're collecting plastic bottles that could become marine debris and recycling those into ink cartridges for HP printers. So a lot of companies are trying to find creative ways to use plastic that's either recovered from the ocean, recovered from beaches, or recovered, on its way to the ocean or a beach. But ultimately, we're looking for a solution where we don't have to figure out what to do with the plastic we pull out of the ocean because we've kept it from getting there.
How do increased recycling rates and goals compare to the increased amount of plastics produced every year? In other words, if the level of plastics being produced every year continues to increase, an increase in percentage recycled plastic does not mean there's less plastic that can enter the environment?
Yes, that is true. We are doing. We have a number of programs to support increasing recycling. As I mentioned, there's the closed loop fund in the U.S., which I don't know that we contribute directly to, but that is a large effort to increase domestic recycling rates. The recycling partnership is something that ACC is a member of, if I can find that. And that's similar to the closed loop fund where we work on trying to help communities increase their recycling rates, whether it's through education, whether it's through providing access to larger recycling bins, or grants to upgrade material recovery facilities. The RAP program is another area where we're looking to expand access to recycling. And then, it's kind of a very slow and boring process of trying to work community by community to increase access to recycling. One of the things that the recycling industry is grappling with right now is the Green Fence or National Sword programs that China has implemented, where they're purchasing less recyclables from other countries. A lot of the recycling from the west coast of the U.S. ends up in China. For whatever shipping and logistic reasons, it's cheaper to do that than process it at home. But with China taking less material, it creates an opportunity for domestic recyclers to increase their operations. And so we should see in the next few years an increase in recycling domestically here in the U.S. But back to your original question, we are producing more and more plastic for more and more products, and we need to continue to increase recycling infrastructure and availability and access in order to ensure that those materials don't end up in the environment.
It was good to see the increase in recycled plastics over time. I was wondering if the proportion of plastics produced to plastics recycled has also increased. I guess that's kind of the same question.
Well, and it's a good question. I don't know the answer to it. I don't know the answer to that.
What about microplastics that are fragments from large macroplastic items like plastic bottles, caps, silverware, etc.? What can be done to reduce the amount of fragments found in the environment?
Well, the approach that we have taken, that ACC has taken, and with the Trash Receives Alliance, is to focus on keeping plastic out of the environment in the first place, so that we don't have the situation where there is an opportunity for plastic to become fragmented. So that has been the approach that we've taken. That being said, we are supporting a research project with some colleagues up in Woods Hole, the the Marine Biological Laboratory and Woods Hole Oceanographic Institute to look at how plastic breaks down in the marine environment, just to see if there are opportunities there where we can be addressing other aspects of that problem. But the first course of business for us is to keep plastic from getting into the environment in the first place, so that we don't have the opportunity for it to break down. One thing that I would mention, and this maybe gets back to another question, the energy bag program, which is something that Dow started a number of years ago. They're partnering, I think, with GLAD right now, and it's a program to take the hard to recycle or the non-recycled plastics and divert them from landfill, and to either use them in a pyrolysis or other process to basically recapture, either recapture energy from them or turn them into synthetic fuels, synthetic transportation fuels, like a synthetic diesel or other product that could be used as a transportation fuel in the U.S., or as we're seeing more and more in developing countries, as a fuel to support energy generation, where they have a lot of diesel generators to produce electricity in some small island developing states and in other countries. And rather than importing that diesel fuel, if you could produce a synthetic fuel that you could then run through a generator, it would reduce your reliance on importing that fuel. It would reduce the carbon impact of producing electricity, and it would also provide an opportunity to deal with some of the difficult to recycle plastics. So not an answer to that question, but just kind of building on some of the questions I've heard.
Do we have any more questions?
I know there have been a lot of companies in plastic to fuel technologies. So could you talk about what is the biggest hurdle in improving the economics of these depolymerization technologies, so that this plastic can, at least the non-recyclable plastic, can be depolymerized to crude oils, and then it can be used to produce more chemicals or fuels?
That's an excellent question, and I have a colleague here that actually chairs a plastics to fuel working group. I don't know that I could answer the question, what is the greatest hurdle? My understanding is that economics are the greatest hurdle right now, but the technology has been improving. Agilix's technology to take expanded polystyrene back to styrene monomer has been making great strides. Other companies that are involved in that space have been working on taking plastics back to industrial waxes and other chemical feedstocks, which can then be refined to produce chemicals for other industries. But what I would do is, my contact information is on the slide. I would encourage you to reach out to me, and I can put you in touch with my colleague Craig, who can answer that question in a far better way than I can. And just as a general comment, because I know we're kind of running out of time here, if folks do have follow-up questions or would like additional information, please feel free to reach out to me by email. I think the slides will be made available to those who attended as well.
Yes, the slides will be available online, as well as the recording within about a week of this recorded seminar. Do we have any more last questions in the room? Okay, let's thank Stu one last time.